Hello everyone. On behalf of Acharya Digital, I welcome you in the revision series of Mathematics paper of Standard 10. In this today's lecture, we are going to take a quick review of first chapter of mathematics, that is real number. For this chapter, 6 marks weightage is there. Now what Cbse says about this chapter? There are 2 points which are important. Number 1, fundamental theorem of arithmetic, and second one, proofs of irrationality of root 2, root 3, root 5. Now here, let us see what do you mean by fundamental theorem of arithmetic. So every composite number can be expressed as product of primes, and this factorization is unique apart from the order in which the prime factors occur. In short, you can write any composite number as a product of its prime factors, and you can change the order of the prime factors, and this combination is unique. That is the meaning of fundamental theorem of arithmetic. Let us take one example. Suppose I am taking a number 280. So if I prime factorize this, what will I get? You all know how to prime factorize, right? 5 7 the 35, 7 1 the 7. So I can write this 280 as 2 into 2 into 2 into 5 into 7, or even you can write this as 2 cube into 5 into 7. So this arrangement can be changed. Order is not important here. Okay, so I have expressed a composite number in terms of product of its prime factors. This is called as fundamental theorem of arithmetic. I hope you have understood. Now let us see how to find out HCF and LCM of the numbers. What is HCF? HCF is nothing but highest common factor. Now here remember the word highest. Now step 1, write the prime factorization of the numbers. Step 2, list the common prime factors of the numbers. Step 3, write the smallest power of each common prime factor. So for highest, remember smallest power. Opposite words, okay? Then next is find the product of these smallest power of each common prime factor. Let us take example. Suppose I have numbers like 300 and let us take 360. So if I prime factorize 300, what will I get? Always start in a sequence. It means like you can take first prime number. Let us check, is it divisible by 2? If not, then go for 3. If not, then go for 5, so that you can get the prime factors in order. Fine. So it's better. Then 275 is a 150, 325 is a 75, 5 5 is a 25, 5 1 is a 5. So 300 can be written as 2 into 2 into 3 into 5 into 5. Or it can be written as 2 square into 3 raised to 1 into 5 square. Second is 360. So again 2 180s are, 2 90s are, 2 45s are, 3 15s are, 3 5s are, 5 1s are. So 360 can be written as 2 cube into 3 square into 5 raised to 1. Okay, I hope you have understood. Now how to find out the HCF? You have to consider smallest power of each common factor. So here for 2 raised to 2 and 2 raised to 3, the smallest one is 2 square. For 3, it is 3 raised to 1. And for 5, it is 5 raised to 1. So if you simplify 2 square, that is 4 into 3 into 5 raised to 1, you will get HCF as how much? 60. 2 square is 4, 4 3s are 12, 12 5s are 60. I hope you have understood. The next topic, that is LCM. What do you mean by LCM? LCM is nothing but least common multiple. Step number 1, write the prime factorization of the numbers. Then list all the factors involved in the numbers. Write the greatest power of the prime factors. Find the product of these greatest power of the prime factors. So same example I can take. I have already done the prime factorization for 300. I think it was 2 square into 3 raised to 1 into 5 square. For 360, it was 2 cube into 3 square into 5 raised to 1. Now, for finding LCM, as the L later shows lowest, so for lowest, I have to consider greatest power. So out of the common factors, first of all, I'll take the greatest power, and along with common, I have to take uncommon factors also. Here, fortunately, we got all the factors as common factors only. So there is no issue of uncommon factor. But if it is there, you have to consider them also. So 2 square and 2 cube. What is the greatest power? 2 cube. 3 raised to 1, 3 raised to 2. Again, it is 3 square. 5 raised to 2, 5 raised to 1. It is 5 square. So if you simplify this, you will get LCM. You can calculate this, right? 8 into 9 into 25. So simplify this, you will get the least common multiple of given two numbers. I hope you have understood the concept. Now let us see the next part, which is very important. Number 1, if A and B are two positive integers, then HCF of A and B multiplied by LCM of A and B is same as A multiplied by B. Let us take one example. If you have numbers like 21 and 6. So if I find out factors for 21, it will be 3 sevens are. For 6, it will be 2 threes are. So here 3 is common. If I want to find out HCF, it is 3. LCM will be common and uncommon. All numbers you have to consider. So it comes to be 42. Now if I take the LHS of this property, so LHS is HCF multiplied by LCM. So 3 multiplied by 42, it comes to be 126, right? Now, if I find out the RHS, what is RHS here? A multiplied by B. A is first number, B is second number. So 21 multiplied by 6, again it comes to be 126. So both are same. That means LHS is same as RHS. So I hope you have understood this. See the next point. If A and B are two coprime positive integers, then HCF of such two coprime positive integers is 1. What is coprime? Coprime numbers are the numbers which have a factor common, and that factor is only number 1. Except 1, nothing is common between them. For example, if I take two numbers, out of that, one is prime, other is composite, like 3, 10. So if you find out HCF for them, it is 1. Nothing is common except 1. If I take two primes, 2 and 5, again HCF is 1. For two composite numbers like 8 and 15, HCF is 1. So two coprimes can be both primes, both composite, or one prime and other composite. Only the condition is they have only one factor in common, and that is number 1. And of course, because of that only, their HCF will be 1. Let us see the next part or the next property. If A is a multiple of B, then HCF of such two numbers is B. Let us take example 20, 10 I'll take, because 20 is a multiple of 10. So what are the factors for 20? It will be 2 2s are 4, 4 5s are 20, 2 5s are 10. So if I find out HCF in this case, how much is the HCF? 2 into 5. That comes to be 10, which is the second number. That means if first number is a multiple of second number, then in that case, HCF of those two numbers is second number. First number is a multiple of second number, then HCF is second number. I hope you have understood. If reverse is the case, if B is a multiple of A, then HCF is A. Same example you can take. Instead of 20 comma 10, if I take 10 comma 20. In this case, b, that is second number, is a multiple of first number. 20 is a multiple of 10. So in that case, how much is the HCF? If you see, 10 can be written as 2 5s, 20 can be written as 2 into 2 into 5. So what is HCF here? HCF will be 10. And what is 10? 10 is the first number, na? So if second number is a multiple of first number, if B is a multiple of A, then in that case HCF is always the first number, that is A. A is 10. Got it? So these are the important points you have to remember, and these important points can be also asked in MCQ. Okay? Now, based on whatever we have studied till now, there is an exercise. You must have solved each and every example from this exercise, and I don't think so there will be any issues in these questions. So if you have any problem, any specific topic or any specific example if you are not getting, please tell me in the comment box so that we can solve it in the next lecture. Fine? Okay. Now next. For any natural number n, will 6 raised to n end in 0? Let us see the solution. If the number ends with the digit 0, then it should be divisible by 5. As we know that any number with the unit place at 0 or 5 is divisible by 5. For example, if you have number 10, it ends with 0, or 15, it ends with 5. So 0 or 5, if they are at the units place, then the given numbers are definitely divisible by 5. Yes or no? And next thing is prime factorization of numbers if they are having combination of 2 and 5, that is 2 raised to n and 5 raised to n. Then and then only that number is divisible by 2 and 5 so that it will end in 0. So let us see the next part of this solution. So what is prime factorization of 6 raised to n? It will be 2 multiplied by 3 raised to n because 6 is written as 2 into 3. Now, if you see here I have 2, but do I have this 5 factor? No, I have 3 instead of 5. So it is not possible to have 6 raised to n ending with 0 because it is not having combination of 2 and 5. For making 10, I need 2 and 5 wala combination. I have 2, but I don't have 5. I have 3 instead, which is not okay. So that's why the given 6 raised to n number doesn't contain prime number 5. So of course, because of that, it won't end with 0. Now, in exercise 1.2, you have to solve examples like prove that root 5 is irrational, prove that 3 plus 2 root 5 is irrational, or prove that 1 by root 2, 7 root 5, 6 plus root 2 as irrational. See how to show root 2 is irrational. I want to show root 2 is irrational, so I will assume in the beginning that root 2 is not irrational. If it is not irrational, then it should be rational number as assumption, right? So let us assume that contrary, that is root 2 is rational number. Now, if it is rational number, you know that every rational number can be written in the form of numerator and denominator. So root 2 can be written as a upon b, and here a and b are co-prime integers. That means they don't have anything common in between them as a factor except number 1. And of course, b is not 0 because it is in the denominator. If denominator becomes 0, it becomes meaningless. Now, next is if root 2 is a by b, then root 2 into b. If I take this b in the left side, I'll take b in the left side. So it will make root 2 multiplied by b equal to a. Now let us square on both sides. So root 2 square is 2, b square is b square equal to a square. So I got 2b square equal to a square. Now, if I have 2b square equal to a square, then b square will be equal to a square upon 2. It means a square is divisible by 2, or 2 divides a square. So if 2 is dividing a square, so definitely 2 is dividing a also. For example, if I take 4, 4 is divisible by 2. So what is square root of 4? 2. So 2 is also divisible by 2, right? 2 divides a square means 2 divides a also. If a equal to 2c for some integer c, then 2b square equal to 2c square. So whatever is given here in the previous step, that is 2b square equal to a square, substitute a as 2c. What will I get? 4c square, right? So 2b square equal to 4c square means b square equal to 2c square. 2 2s are 4. It means 2 divides b square. So 2b square equal to 4c square shows b square equal to 2c square. So b square upon 2 is c square. That means 2 is dividing b square, or b square is divisible by 2. So definitely b is also divisible by 2, like previous state. Yes or no? So next is from statement 2 and 3, what can I conclude? 2 is dividing b also, and it is dividing a also. So can I say that 2 is a common factor of a and b? Yes. But if it is common factor of a and b, then will a and b remain co-primes? Because co-primes don't have anything in common except number 1. And we have showed right now 2 is a common factor. That means our assumption root 2 is rational is wrong. It can't be rational number. That means it has to be irrational number. Hence the proof. This indicates that our supposition or assumption of root 2 is rational is wrong. So root 2 is irrational. I hope you have understood how to prove root 2 is irrational, or root 3, root 5, root 7 as irrational. Same procedure is there for other numbers. Now next example. Show that root 3 plus 7 is irrational. Let us assume the contrary, that root 3 plus 7 is rational. So if it is rational, I can write root 3 plus 7 as a by b, where a and b are integers. If I shift this 7 to the right hand side, I will get root 3 equal to a by b minus 7. Now here a by b is rational number, 7 is rational number. So their subtraction will be of course rational number. Let us consider this subtraction, that is right hand side, as p. So root 3 equal to p. But root 3 is irrational number. We have seen in the previous example that root 2 I can show irrational. Similarly, root 3 is also irrational number. And p is rational number. So irrational number is same as rational number. Is it possible? No. So why this contradiction is happening, or why this false equation is obtained? Because our assumption is not correct. Our assumption is wrong. As this is not possible, this indicates that our supposition root 3 plus 7 is rational is wrong. That means it is not rational. It has to be irrational. I hope you have understood how to show root 3 plus 7 as irrational. Now, some students are committing a mistake. What is that mistake? In this case, they are showing root 3 as irrational number, but it is not expected from you. You don't have to show root 2, root 3, root 5 as irrational number in such kind of questions. If it is asked show that root 2 is irrational, root 3 is irrational separately, then you can prove like previous slide or previous example. But in such combination wala example, you don't have to prove root 3 as irrational. You have to assume it is irrational because already we have proved. Okay. Now, what am I expecting this time in the paper is instead of having numbers, alphabets can also be given like X and Y. So if X is a rational number and Y is irrational number, then prove that X plus Y is irrational. So same procedure you have to follow. So you will assume, let us assume X plus Y is a rational number. So here X is rational, Y is irrational. So that rational number I'll assume as A by B, where A and B are integers. X is rational. A by B is also rational. So I'll keep Y on left side and I'll shift that X on the right side. Rational, rational on right side. So here A by B minus X is a rational numbers subtraction. So it will be of course again rational. So let us assume that this as P, rational number, right? But Y is irrational number. It is given. Y is a rational number, which is same as rational number. So is it possible that rational number and irrational numbers are same? No, it is not possible. That means our assumption is not correct. It is wrong. So given number is not rational. So of course, if it is not rational, then it will become irrational. So such kind of question can also be asked. Instead of numbers, alphabets can also be given. You must be able to prove it in the same manner. Fine. Okay, that's it for today's lecture. If you have any doubt, please mention it in the comment box. Accordingly, I can take your revision. Thank you so much.